Okay, in this video, I'm going to show you how to pick random numbers using subscripted variables. So I'm going to call this program random numbers 1 through 52. Our second line, we're going to reserve 52 spaces in memory for variable C. Now C is going to be our subscript. If you are doing 10 or less subscripts for C, you wouldn't have to do this. But since we're doing more than 10, you have to reserve enough memory. Otherwise, you'll get an error. So our second line is going to be for A equals 1 to 52, which is our 52 cycles of B, which is going to be random numbers from 1 to 52. But we don't want the computer picking the same number twice. Now, if we left the program as is and printed B and asked for next A, and we ran this program, we're going to end up with 52 numbers, but they're going to be repeated here. We have 3 37s that I can see. We have other repeated numbers, I'm sure. 2 35s, we do not want that. Okay, the reason I'm using the number 52 is because that's the number of cards that there are in a deck of playing cards. So I want this to relate to something, and so that's the number that I like to use, and that's the number I'm going to use in this video. So we have to delete lines 5 through 6 and add some more lines, otherwise we're going to get 52 numbers, but they're going to be repeated. And in a deck of playing cards, there's only one of each card. So what we need to do is we need to say if if C of B is greater than 0, then it needs to pick another card. Okay, so what's going to happen is we're going to clear memory here. We're going to go through our first cycle. It's going to pick a card from 1 to 52. Let's say that card is 10. And it's going to come down here and it's going to check to see if 10 has already been used. If it has, it will have the subscript here will have a value greater than 0, and it will be asked to pick another card until it picks something other than the same card, and that happens on our next line. Now, the first time we run the program, it's going to pass through to line 6. Because all of the 52 slots of C are open and they all equal 0. A variable always equals 0 unless you give it another value. To demonstrate that, I'll put print Z equals 0, print X, print Y, they all equal 0 unless you give them a value. So we're going to give value to C. Now the first time it's going to pass through, and we're going to say C of B equals B, and this is going to prevent the computer on the next cycle from picking our first card all over again. So say if the computer picks out of these 52 random numbers, it picks 10 on the first try. It's that slot will C10 is empty at this point, so it's not going to be greater than 0. But when it comes down here, C10, it has the value of 10. So what this line 6 is basically saying is that C subscripted with the B that it just found equals a value other than 0, which is 10 at this point. And so if on the next cycle it picks 10 again, C subscripted with 10, if it chose 10 again, would have a value greater than 0. It would have a value of 10. So then it will be instructed to go back here and pick another number. Say it picks 11. Now C subscripted with 11 has a value less of 0. So it will be sent down here, and that will be recorded. So it will not pick 11 again. C11 equals 11. So anytime it repeats a choice, after it's been recorded here, it will be instructed to keep picking numbers until it picks something other than the same number. So the only other line number we have to add now is print, what are we going to print here? We're going to print B. And then we are going to ask it to go to the next A, and that is the end of our program. So by adding these other lines down here, we're not going to get repeated numbers, and that is going to be demonstrated with a slowdown of the processor, if you notice. And the reason it's slowing down this time is because it picks, it's random numbers. So anytime it hits a number that it's already picked, it's being instructed to go back and pick another number. That's why the processor slows down, and you can see that in the speed of the numbers. So we can go through this and show that there are no repeated numbers. We have 1, 2, 3. We have 4, 5, 6. Where's 7? 7, 8, 9. Where's 10? 10, 11, 12, 13, 14. Where's 14? 14, 15. And where's 16? It's got to be 16 is right above it. There's 16, 17, 18, 19, 20, 21. Okay, where's 22? 22, where's 22? 21. 22, where are you? It's got to be around here somewhere. 22, 23, 24. There's 24, 24, right below it. 25, 25, 26, 27, 28. Where's 28? There's 27, 28. Where's 28? 28 up in the left hand corner. 29. It's got to be somewhere. There's 29. Where are you? 29. 29. Going once. Can't find it. It's 29. Let's go line by line here until I find it. 29 down in the right hand corner, 30, where's 30, 30, okay, so we're to 30, 31, 32, 33, 34, 35, we're almost there, 36, 37, where's 37, 37, 38, we're almost to 40, 39, 40, okay, that only leaves 12 more numbers, 41, 41, okay, looking for 42, there's 42, there's 41, 42, it's gotta be around there somewhere. Sometimes the numbers get divided in half because of the screen, but I don't see any numbers divided in half. I can't find 42. It's got to be somewhere. 42, there it is. 43, 44, 45, 46, 47, there's 46, 47, 48, 49, 50, 51, and where's 52? 52. So all numbers are represented, none of them are repeating, and this is the first step that you need to do if you want to pick a number of random cards, inclusive, meaning every random card that you put in here is represented and none of them are repeated. So that's how you do that. And this can be used to make a card game. It's kind of like a operations center, for lack of a better term, a logic center, something like that, that can be used as part of a bigger program. And so in my next video, I'll show you how to make an application using data lines and a text, I guess a text version of a card game, which is, you could do that in a day or two, versus the one that I did on a previous video, which took me months, several months. And it's amazing. You can make a text card game in a day or two, but if you want graphics, you're looking at months and months and months of work. And trust me, I've been through it. I didn't know it was going to take that long. I knew it was going to take a while, but not, 6-7 months. But that's how long it took. So you can have your choice of, how fast you need program finished or whatever. You can do it simply, just using text. Or you can go for graphics. Depends on the level of graphics that you want, but trust me, making a full card game like poker is going to take a long time. But this is part of it right here. I had to figure this out. This subscripted variables are referred to in the extended TRS-80. The extended color basic. This is referred to, but they do it in a slightly different way, which wasn't working too well for me, so I came up with a better way. They both do about the same thing, but this is a better way. So, if you want to read about subscripted variables, you can do that. It just means that you are making a variable that will accommodate more than one value. So A can have 100 different values, B can have 100 different values, and this condenses a very, very long program into a short little program. Otherwise, you'd be typing your life away if you had to do this 52 times. You'd have, I don't know, you'd probably have 52 to 104 lines of code. And this cuts it down to 8 lines. I think I'd rather do 8 lines. So that's it for today. I hope you enjoyed this video. Take care.